Logic likes to pretend it's very clear and always accurate, but there are some really weird parts of logic, and I think it's important to show that although logic is incredibly useful, it's not a perfect system and we still have things to learn. That said, the rest of this video might make your brain hurt a little bit. Don't worry, these things are much more complicated for the future, but I want to introduce them so you know that they're coming. There are some statements that cannot be given a truth value. These are called paradoxes. For example, the statement, "this sentence is a lie," is a paradox. I am stating that this sentence is a lie is true. But if I'm telling the truth, then I'm actually not lying to you, and therefore the statement is false. However, if I am lying to you when I say that I'm lying to you, then the statement is true. So I'm not lying to you. We cannot give this statement a truth value, even though it seems to be declaring something clearly like statements should. Paradoxes can be quite confusing, unsurprisingly, so we're not going to go into them any further, but they are an interesting part of logic, and trying to untangle these strange effects is how we create new ways of thinking. There are also other types of logic. I said statements must be either true or false, and in regular logic, that's right. This is often called Boolean logic after the mathematician George Boole. But there is another form of logic with degrees of truth. For example, a statement might be 30% true and 70% false. This is called fuzzy logic, and it was first investigated in the 1960s. Fuzzy logic is an important part of modern computing and AI systems. It tries to use the ideas of logic on situations which are too complex to easily break down into Boolean logic. We're going to stop talking about fuzzy logic now and stick to more formal logic in these videos. We said at the start that logic is the foundation of maths, but we haven't really seen any maths yet, have we? For now, just remember that logic is based on axioms, and maths has to use some axioms to start from, which we can look about in the future. But think about this. Using the symbols we have learned so far, we can make the argument that if I have one thing and I have another thing, then I have two things. 1 plus 1 is 2. To be clear, this is absolutely not how mathematicians prove that 1 plus 1 is 2. That can take hundreds of pages, and no, I'm not kidding. Finally, I need to say what logic is not. Logic is not morality. Some people forget this sometimes, but in logic we focus on what we can say is true or false, which is not the same as saying what is right or wrong. The two do cross over sometimes, and when they do, people get pretty upset about it. But enough of that for now. No one can go from what is true to what should happen. This is sometimes called the ought-is problem, and if you don't believe me, try it. See if you can logically derive I should from it is true that with no suppressed premises. If you can, then your Fields Medal in Mathematics is waiting for you. Hi there, hope you found that interesting. Like, comment, subscribe, etc. If you prefer longer videos, you can find these lessons stitched together on our other channel just up there. But whatever you do, please keep learning something, because no matter who you are or how old you are, every day really is a school day. Bye for now.